Hello everyone. Now let us consider the analogy between the Diffie-Hellman key exchange and elliptic curve key exchange. Okay. So before considering this analogy, here we are going to consider the order of elliptic curve. So order of elliptic curve is represented as n. So I'll just mention here order of EC, that is n, which is nothing but total number of points on curve on curve plus point at infinity. Okay, so this is known as order of elliptic curve. And now let us consider the analogy between the elliptic curve key exchange and Diffie-Hellman key exchange. So here I'll just write comparison. Okay, so when I'm going to consider elliptic curve key exchange, and Diffie-Hellman key exchange. Okay, so here in case of elliptic curve key exchange, what we are going to do means we will going to publicly announce the elliptic curve group defined over a prime number and a constant, and the corresponding point which we are going to use in calculating the key as well as in sharing the finding the public key. So here also we are going to consider the prime number q. In case of Diffie-Hellman, we are going to use the prime number q, which is commonly used by both the users, that is O and alpha. So this alpha is a primitive root and this is q, and similarly here we are having g and e, that is known for both the users. Now let the user A will going to select his private key NA, and it should be less than n. What is n? Order of the elliptic curve group. And user B will going to select his private key which is less than n. That is nothing but both NA and NB must be less than n. And in case of Diffie-Hellman key exchange, what we are going to do? Here both the users will going to select their private key, that is XA, which is less than Q, and YA, XB, which is less than Q. So now using the private key, we have to calculate public key. So here what we are going to do? We are going to calculate public key as primitive root to the power of XA mod Q. And we are having public key of B as primitive root to the power of XB mod Q. Similarly, in case of elliptic curve cryptography, we will going to calculate public key, that is PU, or let me consider it as PUA. So public PU represents public, PR represents private. So this is PRA and this is PRB. And PUA is nothing but NA number of times G. Means I'm going to repeatedly add the point G NA number of times. And similarly, public key of B is nothing but NB number of times G. Repeated addition of G NB number of times. And the next thing is we have to exchange public key to find out the session key. So here I can express session key as the product, that is public key of the other user into private key of the user A. And here also I can represent this as KS as public key of user A into private key of user B. So now we know that we can write PUB as NB times G into NA, and here this is also NA times G into NB, which is nothing but NA into NB G. This is also NA into NB G. Okay, this is how we are having a common session key with both the users using elliptic curve cryptography. Similarly, when I am going to consider this Diffie-Hellman key exchange, I will be exchanging the public keys YA and YB. So how I will calculate session key? Session key is nothing but public key of the another user to the private of to the exponent of private key, his own private key mod Q. So here also Ks is nothing but Ya to the power of Xb mod Q. So according to this, I can express Yb as alpha to the power of Xb whole to the power of Xa mod Q. And here this is nothing but alpha to the power of Xa whole to the power of Xb mod Q. Okay. So this is same as alpha to the power of Xa into Xb mod Q. And this is same as alpha to the power of Xa into Xb mod Q. So here also both the users are having common session key. Okay. Now, when we observe Diffie-Hellman key exchange as well as elliptic curve key exchange, here we are doing repeated addition of a point G, but here we are taking exponent with respect to the primitive root alpha using both the private keys. Here NA and NB are private keys of user A and B, and here also Xa and Xb are private keys of user A and B. This is how we can exchange session key using elliptic curves and Diffie-Hellman. This is the analogy or similarity of key exchange using elliptic curve and Diffie-Hellman key exchange. Okay.